First of all, I would like to say that the presentation will be in English. My good friend Eirik, I know him for 27 years. Him and I, we actually speak Norwegian/Danish, and sometimes we pretend it's okay, but in reality, there are some things slipping here and there. And since this is a technical area, my presentation for you will be in English. I hope you're okay with that one, as usually is. The standard that I'm going to introduce to you today, the RDS, the Reference Designation System, is the same as the ISO IEC, NEN and NEK, etc., standard we're talking about. But it's just complicated to say 81346, so for daily life, we just call it RDS. The standard has been a part of my professional life since 1996, where I actually met Eirik the first time. And I have used it in my 20 years as a consultant working for Rambøll for a lot of different kind of things, just using it as the way it is. And since 2010, I've been using it very actively in my own company, where we assist people in the first steps toward implementing it, even expanding it, as well as really understanding what's going on. And we have taken it even further and used it for a lot of really cool stuff you can use it to control complexity with. Even though the standard is something that I use on a daily life basis, it still comes to me, if not on a daily basis, then at least on a weekly basis, something new I can use it for. I think it must be like having a music instrument to play, even though you're very good at it. I mean, I've got 34 years of experience with that kind of things. You need to learn new graphs, new things, and new tones you haven't explored. And I feel I have it the same way with RDS as well. So it is indeed a very integrated part of my life, and even my family has accepted it as a kind of thing we needed to repeat in our family as well. My name is Henrik Balslev. I have a background as an electrical engineer. That's actually where it all starts, from electrical engineering. Don't tell the mechanical guys because they might get a little bit upset about that. But nevertheless, it is from electrical engineering this standard originates, which we will tell you later on. And I'm here today to share with you some of the insight and some of the things I've learned personally, because I still tend to learn about it, and put that all in a nutshell called 1 hour lesson for you today. My presentation takes 50 minutes, and there is a little surprise for you at the end. I think I'll surprise you a little bit there. And there will be also time for some additional stuff as well. I've got 2 practical things I would like to make sure that you get. First of all, I will have to leave at 2:30 in the coffee break because I have to catch an aircraft to go to Amsterdam. Unfortunately, I've got another appointment down there tomorrow. So if you want to speak with me, and I really want to speak with you, don't hesitate to contact me, but before 2:30, otherwise it's too late, and then you have to write me an email. Then I have to press this button. I have to press it hard, okay. So the agenda for today, with these few words, here comes the agenda for today. First of all, I would like to introduce you the basic conditions for understanding what 81346 RDS is about. I'm going to introduce to you something that came to me 3 years ago as a really eye-opener, even though I've been working with it, as I said, day in and day out. 3 years ago, I realized what RDS really is about, really, really in a nutshell. And of course, I'm going to share that with you today as well. You can't really do anything without examples, so I brought a very detailed example for you, and you better get used to it, because first of all, I would like to take you through it so you can see what it's about. You can get it for free. You simply scan a QR barcode. I also brought some mini flyers up here. They will be on the screen as well, but if you miss it, there's a mini flyer for you. Put it in the bag, take it home, scan it, and get this example for free, and share it with your colleagues as well. But it's up here, and I'll leave these ones for you. Furthermore, after lunch, because it's too much, you have to listen to us this morning, so it might get a little bit dizzy. After lunch, it's even worse, because now you have got food, and now you're ready to work. So in the afternoon, just after lunch, you will have to work with this exact same example together with us, the rest of us. So I would advise you to bring your smartphone. It's actually upside down to say that. I should tell you to leave it at home, right? So, but you need your smartphone or something like that, or you need to work together with someone to address some of the coding principles so you can see how it actually works in real life. Not just listening to it, but actually try it in real life after lunch. We very often get the question around all right, we want to do 81346, but we have a lot of complaints in our organization. What should we do to actually make it work? And after working with this standard for intensively by implementing it for over 13 years, I would like to share an implementation strategy that actually seems to work. It's not a miracle. It's not a miracle cure, but it certainly has some very practical approaches for how you should do it. And I've cooked it down to 3 essential things you need to know about. I'll get back to that one. We must also realize that running a thing like RDS without a tool is a no-go. You need some tools to make it work for you. And I would like to share the tools and the things you can actually stand on shoulders on already, and share that with you as well later on. Finally, there will be 10 minutes with questions and answers, so you've got plenty of time. To be able to do that, please note in the bottom right corner there's a slide number, in this case number 2. And in case you want me to go back to some of the slides, I'll ask my nice technician guide in the back to go back. You just tell me the number and we'll get back to it, and if there's any clarification questions. So please pay attention and summarize your questions until then. Okay. Before I start, please allow me just to give you a brief introduction about our company. Systems Engineering AS was founded in 2013. And what we deal with is we deal, first of all, as an always infrastructure baseline, we always use 81346, either by telling the client we do it or not telling them. We actually use the technique for every baseline we do. As you can see here with the 4 selected pictures, we work with big plants. In this case, it's a cement plant, top left. We work a lot with renewable energy. I myself are deeply involved in some of the plants in this case, you can see the transformer platforms, top right, and all the wind farms. A lot of electricity, yeah. And that is something that really needs a way of structuring things, and that's what RDS is very good at. We work both for the client side, Ørsted, but we also work for the contractor side, in this case, Semco Maritime, and they all benefit from the knowledge about 81346 and how to organize complexity. We work with hydrogen and manufacturing hydrogen, which is the box left to the bottom. We have what we see in the green area of green energy is a lot of people are attracted to this new area, and a lot of people need to start working with new areas and new engineering fields, bringing a lot of experience from different fields, but they don't really have a common ground to stand on. And I think that's what RDS can actually offer you, a common ground, a common understanding of what you're doing, so you can actually work together much more easily. Finally, but not least, sometimes you are lucky, and even though we had a very small start, we met Airbus back in 2014, where Airbus fell in love with the RDS principles that I'll show you later on. And we said, I mean, we were that big company at that time, we were just 2 persons. And they said, we would like to work with you guys. They said, yeah, I'm so lucky. And well, it doesn't work like that. So it took 3 years to get momentum. But in 2017, we started the journey and the partnership with Airbus to see how RDS 81346 can make a difference for them in their digital efforts. And that some of the things that you will present for you today, some of the results we have created. Also the new part 14 and new part 50, which are pending, is actually a result from that work as well. Just to say that it has a practical background as well. I will not mention the other references, never mind about them. What they all have in common is complexity. Things get more and more complex, things get more and more integrated, you need more and more sophisticated tools, you need to integrate with the cloud, you have systems of systems which has to interact, and RDS can handle all of it. That's pretty amazing, isn't it? You just need to learn the technique. So with this very brief introduction, today, by the way, we are 10 persons. We're located in Copenhagen, and we have 6 programmers sitting in Poland doing some of the tooling stuff that we offer as well. So the first step towards understanding what RDS is about is a premise I need you to buy in on, and that is that you need to think in systems. Just to give you a small example, if we take a human being like ourselves, in fact, we are divided into 11 systems that I'll show you in a moment. So in fact, other industries, in this case, the medical industry, actually have divided a thing like us into systems. It's quite obvious if you have a beauty flying like her. Aircrafts are female, just like ships, by the way. That's actually one big flying system with subsystems, etc. And one of the things that I was introducing, I still remember I was standing more or less in front of a crowd like you in Toulouse, in front of hardcore flight engineers, and say, we would like to introduce to you that the wing is not a wing anymore, it's a lift system, and so on and so forth. And the fuselage is a containment system, and so on. And I said, this is not going to work. And they said, this is what we've been waiting for 15 years, so get on with it, more or less. So check, we're on the right spot. And of course, if you get a thing like this, of course, everything you see there are systems. Even the handrails is a part of a safety system, and so on. So you need to tune in that RDS handles and can only see systems. Is that okay with you? A lot of knots around. So if I ask you a question, please raise your hands and give me a thumbs up. And say. So from now on, understanding RDS is about understanding everything, and I mean everything is about systems. Okay. Just to get the definition right, I took the definition from our standard. System is a set of integrated objects considered in a defined context as a whole and separate from the environment, and then a lot of notes to explain what we actually mean. To be practical, this is a system. You put together some things, 2 push buttons and a laser beam and whatever it is, and by that you actually get something new called a new system. And we call this a component system in RDS. In principle, if you focus, this is a system too. I know you call it a pen, but at the end of the day, it's a cap, and there's a chassis, and there's some ink. If you put it together and you put your system thinking glasses, this is a system, and so on. Okay, so system thinking is a key. And just to underline how humans are divided, as you can see yourself, muscular system, cardiovascular system, nervous system, etc., etc. It comes in 2 flavors. Our reproductive system is in fact 2 flavors, male and female. So doctors actually think of us as a system. Last time I was with the doctor with a small thing, I noticed that she actually had 4 of these systems hanging on the wall. So I do suspect my doctor to inspect my systems and not me, to be honest. But on the other hand, if it works, it's fine. So we are not the only one thinking in systems. If you want to have fun Friday afternoon, we got this from the internet. You can get the reference later on with a clear reference. You can just try to Google human systems, and then there's actually a homepage where you can switch the systems on and off. It's great fun, actually. It's great fun. Oh, that system, that system. So when you get it, you cannot unsee it anymore, promise. The mission we are on is what we call to create a common language. And we are serious when we say that RDS is about creating a common language. There is another industry which already has a common language, and that is music. Does anyone of in here read music keys and notes? Yeah? 2, 3, 4? Yeah? We got a common language, don't we? And the rest of you, too bad for you. But we can play together. We know the premises. We know how to read it. And it's the same mission we're on. Now, I mean, can you imagine that you ask 4 musicians here, just group them together and say, go on and play. Come on, play, get on with it. I mean, you can jam. If you are, of course, if you are an orchestra and you're well played, you don't need keys and notes. But if you get big, if you get complex, for example, having an opera or having 50 people on stage, or a big orchestra with 100 people playing together, you can't live without keys and notes. It's not possible. If you want to convey information about music, it's also a pretty smart way of conveying information, isn't it? You put keys and notes on a sheet of music, and then here we go. It's the same mission we're on. So in case you don't know, to the left is called keys and notes, G, F, and C key, and the notes in it. So, and by these things, you can play anything for hours, endless, and tons of people playing together. You can even convey it over borders if you like to. Play the same in India if you like to. That's pretty amazing, isn't it? So this is the common language for musicians, and I would like to claim that RDS is exactly the same we have, but for engineers. It works a little bit differently. We have system thinking. This one shows that when you have a system, the system contains of system elements, push buttons, etc. So that's the premise. We have this triangle that I will take you through quite a lot of times today, so I will not dive into it, but that's where you find all the elements of what you build systems for. And finally, but not least, you cannot have one system that you can only view from one angle. You need multiple angles to view the system from. And that's what RDS is defining for you. You just need to learn what it's about. Of course, the price you have to pay, just as it is for the keys and nose left, you need to know, all right, how does it work? But it is there. It is Norwegian standard, it's European standard, it's ISO standard, and it's IEC standard. It's all over the world. And believe me, it's spreading fast, very fast. We are having an online training course that we invited free of charge here the other day. And I was surprised to see that within 2 days, we got over 200 people who wanted to join the course. And I asked my engineers, where did they come from? And the answer is all over the world. They come from all over the world, even from New Zealand. So the interest is definitely there. The interest is definitely there. The triangle is quite essential, and I will take you through it also after lunch, but I would like to explain a little thing about it. You see, when we want to discuss about what systems are and where you can find them, this technique actually works like Lego bricks. So we asked Lego if it was okay to use their technique as a metaphor. I allow myself to think that everybody in here knows Lego from Denmark. Check. We got the same idea. So you can see in the bottom here, which is the RDS standard later on, we have put things like cables and terminals and switch gears and transformers and motors and stuff. You find all the basic elements down there, doors and windows and so on. You find them down there. When you then aggregate them to something larger, you get something like this. You get a cabin system, a base frame system, so a larger whole that you put things together in, computer systems, etc., a staircase that I'm looking at. And then you got the entry systems, the main systems as we call it, which is the main parts that you can actually get. And at the end of the day, you put that into a box. We call that a top node, but it's the same philosophy. So the triangle is a picture of a repository from where you pick things as an engineer that you can do things with. We call the top level industry systems, the mid-level technical systems, and the bottom level we call that component systems. And the numbers in the parentheses are the numbers of classes that you can search for. So we have around 620. I didn't count the largest one you did. I think we're around 700 now, something like that. But around 600-700 things that you can, as an engineer, build from. Again, terminals, switchgear, cables, wires, etc. 700 things, yes, but it's for everyone. So as last time I counted as an electrical engineer, we deal with around 150 electrical components, things, cables, and so on. So it's a shared repository, doors, windows, covers, anything, valves, anything that mechanical, electrical process, etc. engineers wants, they find them down there. You aggregate that to be technical systems, and I'll show you in a moment. That will be industry dependent, but there's around 60 and 80 in between that kind of systems. And the entry systems is always a relatively small, below 20, by which you more or less enter the industry, as I will show you later on. So if you want to design an aircraft, you have 14 systems, which gives you a picture of the aircraft, of the systems, and then you can subdivide it into technical systems and so on. Later on, you will hear Torleif. Torleif, raise your hand. Yeah, Torleif will tell you about the Ready project, where we did the same thing with Norwegian engineers around the oil and gas sector. Same thing going on. What kind of systems do we see in the entry and so on? I'm sure that Torleif will explain about that, and so on and so forth. So it's the same thing going on. Now, what you do then is that you concatenate things, just like Lego bricks. You put things together, so you have something which is built of something, which is built of something, which is quite obvious. So, of course, you can have a component system and a technical system in an industry system, but you can also have a technical system in a technical system, and even a technical system and a technical system, and so on. You can also have a component in a component system in a component system, and if I steal this one, and if I take this one, may I use your pen, please? Thank you. So, for example, speaking of mechanical engineering, if you have a beam and you put 3 beams together to make a new beam, you have a beam made of beams. I mean, what's not to like in that? Which one was yours? That one, all right. Thank you very much. So you can have, there are endless ways, just like Lego bricks, endless ways of combining it. But there is a way of organizing them so you know what we're dealing with. So we have decided, we are the guys behind the standards, have decided that we always use a 1-letter code for the industry system, we use a 2-letter code for the technical system, and we use a 3-letter code for the component system, so you always know what you're talking about. And I will challenge you about this later on as well. so you can see for yourself what we're talking about. Today we have, speaking of the triangle, you will find everything in the bottom, you will find that in the part 2. And to be very, very practical, who are the organizers and who are in charge of it? We are. The chairman is here. It's Erik Selvik that you'll hear in a moment. We participate, and Klaus Eggeberg, I don't know if you are online, Klaus, but he participates. So it's a question of us maintaining it and making sure it gets updated. And the 2 things we didn't find at the Reddit project, namely 2 different valves, of course, we did put them in, so we remember that. As you can see, we have construction works that you hear later on, and we have power systems that you, Ellen, will talk about. And the whole point, as you can see, the only way of getting around it is to make a industry-specific way of thinking of systems. It doesn't make sense to make a one big fat standard that talks about everything in the whole world, but the reason behind having the triangle making industry-specific is simply to make people feel at home. Simply feel. So if you are a construction guy, you go to part 12, and here you go. Everything fits for you. If you are in the power system sector, which by the way very much originates from green energy, from the project we did here with Energy Norway. That's what I wanted to say. So that originates quite a lot from Norway as well. And it has to be industry specific, so you'd speak about power and so on. You would hear about manufacturing and so on later on. What's pending is that the manufacturing system is about machinery, machine that does production. It's very much funded on a work we did with Tetra Pak, who wants to convert to this way of thinking as well. I know you'll speak about oil and gas. I spoke with Airbus yesterday, and they have big ambitions about making the same for aircrafts come public available, and so on. So the top of the triangle is always industry specific. So far, so good. Now, I'm going to share with you a really aha experience that I gained 3 years ago. So you should now, in principle, be familiar with the system thinking left, the triangle from where you pick systems, and the different kind of angles you see. We haven't talked about that yet, but don't worry, we'll get back to that later on. So what do you actually use RDS for in a nutshell? This is a engineering silo where process engineers sit. Does any one of you sit in an electrical silo in daily life? No? None of you? No? All right. In the rest of the world, except Norway, they sit in silos. They sit in electrical silo, process silo, mechanical silo, and process. And they tend to be difficult speaking with each other. But in Norway, you just fine. So okay. Pretty cool, I'll say. But assuming, if you can imagine that one, we make, in this case, the process engineers make diagrams. In this case, it's a diagram, it's a hydraulic diagram. And on the other silo, we have mechanical engineers, and they do such an attractive thing as 3D models, which is a geometrical model. The thing is that the model left is designed for flow information, and the model right is designed for physical dimension information, geometry, and things like that. And one is not better than the other one. It just happens to be 2 very different ways of expressing it. The problem around it is, if we expand it further, we also have a model around manufacturing, assembly and manufacturing, and we also have a service manual. Now, the problem is, in all these models, the same thing applies, namely the hydraulic pump shown in the middle. So, how do these models actually know that they are talking about the same thing? How do they know that? The answer is they don't. They don't. So we actually have 4 silos who speaks completely different languages, and you can add whatever you like as well. And this is what RDS does for you in a nutshell. What it says is that, all right, the thing here is that it is the same thing. So we need a mechanism that allows you to address that we're talking about the same thing. And that is what RDS does in a nutshell for you. You can see the triangle in the middle. For graphical purposes, it's just blue. Never mind about that. And on the top left, you can see that we have made a system breakdown, made from a functional point of view, that makes the sense for the process engineers. I would say very often process engineers and electrical engineers share the same model of a system breakdown. It makes very good sense. Whereas to the right, for the mechanical engineers, they make another breakdown that makes sense for them. But you represent what you're thinking about in a system breakdown in a certain way of thinking of it. And RDS, since you use the same language, allows you to do identical ways of making the models, but not identical models. You make a model that is relevant for your specific silo. Do you follow me so far? Okay. So the point is that we want to look at this one, and I was looking at this. I'll cut the story why I did it, but I was looking at this from a distance as a part of the Abonner project, and we realized that what you're actually looking at up there is what I would call a reference model. And then it just came to me, that's why it's called a reference system, because you refer to it. It's called a reference designation system because you use the technique to refer to something. And what is it that you refer to? You refer to a reference model. The beauty about the reference model is that it's neutral. It's not discipline dependent. It might represent some certain disciplines and way of thinking, but it's not reserved for a certain discipline. It is in the purest form a natural point that you can refer to. That is pretty elegant, if you ask me. It also turns out that that model is something that people are looking for when they want to go digital. All the efforts about digitalization, etc., etc. People push a lot of money into making the 3D model of the center of gravity. It doesn't make sense for an electrical engineer. It just doesn't make sense, not at all. Because the 3D model is geometry orientated and electrical engineers think in functionality. It's as simple as that. So you need a neutral ground, common language, and that's what the IDS is about. That's also, by the way, what the coding principle is about. That's a 3-letter code. Do you remember what the 3-letter code was about? It's a component system, right? The 1-letter code, 2-letter codes, and 3-letter code. 3-letter codes is the same as a component system, a thing like this. And what's missing now is the only thing is that we need to relate them to each other. So the pump you see left is the same as the pump in the middle, and so on and so on. And how do you figure that out? I had to say, how do we figure out that that's the same? And the only way when I meet a problem like that is I call Eirik and say I have a problem. And Eirik said the only way to figure that out is to add a human brain and add that as well, so you know what to link together. But if you look at it, it's the GPA that is actually connecting it, so you can actually sort it out quite quickly. And I would say with the different kind of structures and the relations among them, RDS offers you a reference model which is in purest form can handle anything. So we had to write that down in the new part 1, Annex I think it is, how that mechanism works and the rules around it. It also means, to be practical, that I will show you later on, that if you have these different kind of, I'll put a circle around where the hydraulic pump is supposed to be. The 4 drawings you see here is actually just different kind of representations of the same thing, but they point via the reference model to the same thing. So you need to refer to a reference model to be able to handle it. That's what RDS is about in a nutshell. So from now on, when you see a reference designation, it's a reference designation because it refers to a reference model. Are you semi-okay with that? You'll get used to it, but that's the key. That's the key. It has nothing to do with the coding principles. The key is you can create such a fantastic model. And what we see from experience with our new clients, when they've seen this picture, they want one. It's brilliant, and we want one, and we want it now. How do we get it? That's more or less it. All right. Next thing coming up is a practical example. Now I've talked a lot. Let's see how it actually works in real life. And the good news about the practical example is that you can get it for free later on. You can simply just scan a QR barcode. It was up here if you forget it. Or the alternative, if you can't wait, you can scan the QR barcode. I brought that as well with me. But we already started the fun. So on the left side, you see a reference model. And in this reference model, this smells of a building. It's construction work, so it's part 12. And in this one, we just took the first step to say, in a building like this one, you have a ground system, you have wall systems, you have floor systems, and you have a roof system. What's not to like? And then just to open the fun, we have a tap water system and a drain system. Of course, we have electrical supply system, and so on and so forth. The example that we would like to hand out to you and anybody else is the tap water system, because it's a kind of natural thing. Everybody drinks water. That should be okay. So the point is, again, you could see the 1-letter codes, right? So 1-letter code is the entry barrier in RDS CW, where all the main systems of a building is defined. Secondly, we subdivided, in this case, the tap water system into a 2-letter codes. 2-letter codes equals a, do you remember that, technical system? So now we have this one made our technical system. So we have the cold water supply system, the hot water supply system, water distribution system, for cold water, for hot water, and for the circulation. So you don't have to wait for the hot water. That's pretty smart. Before I get on with it, the example is created actually for the Danish construction sector by us. To be able to do that for all the installation disciplines, we had to create our own building. And I was looking high and low to find something useful that I could use as a kind of template behind what I was doing. But I didn't manage to find it, so I just decided to draw it myself. So one afternoon I did this, and since there were no architects around, I got my will. Practical stuff like having a center core where we could put the razors, and I think I put the changing rooms in the bottom, and then of course I have the technique areas nicely collected to the left, but of course in the bottom, and lots of space for installations. I know when the architect comes around, I'll probably be halved or something like that, but I got all the space I wanted. Check. So this is the technique, and we use this as a template for all the disciplines that we have made the examples for. We have then, by the way, we got the rights back, so the example in Danish belongs to the Danish construction sector, where any other language but Danish belongs to us. And we have translated it to English, and it's the English version of the tap water that you will get for free later on. So to be practical, in the bottom here is the P. It's a funny thing, you draw symbols on a physical drawing, but that's the way it works. So down here you can see on the right, on the left corner top, we have the technical installations in the technical rooms, and from where we have the distribution out with water. That should be pretty much straightforward to read like that. Does any one of you have troubles reading P and I diagrams and non-electrical symbols? Are you okay with that? Yeah, most of you can read it, okay. So this should be pretty much straightforward what's going on. And as you can see, there are reference designations on, and there are some 2-letter codes and some 1-letter codes, and a lot of funny stuff about these letter codes. Very often we get the question around the letter codes. So I might as well say it up front. The letter codes have absolutely no meaning. No meaning whatsoever, and there's a reason behind that. So if you try to figure out what that is, you can't figure it out. You need to learn them, but basically you don't need it. We see sometimes, especially when people don't want to move, that they stick to existing letter coding principles. For example, in Denmark we have something called TU for temperature udenfor, and you can't put that on an international recipe. It just doesn't work. So in this case, the point here is that the letter codes has no meaning whatsoever. Let's dive into it. So if we, for example, take the reference model to the right, you can see the letter codes. And just to show you something, for example, the cold water supply system is in fact the thing that you find down here. Are all of you also familiar with the dashed dotted line, what that means? It means that you put in everything into the same box, has the same thing in front of it, namely in this case the HB1. So everything inside that box has an HB1 in front of it, as you can see here to the right. And inside that one you will find some valves and a meter and a regulating valve, etc. Don't cheat, gentlemen on the back seat, don't cheat, because you will get an exam after lunch if you can find the codes yourself. So please don't cheat, okay? No, I'm just kidding, it's okay. Are the hot water supply, when you got the cold water in, then you can, of course, you need to heat it, and this is the heating circuit you can see up there with some pumps and etc. etc. Straightforward so far, right? All of it applied with RDS codes from RDS CW part 12. Here we go. Then we go to the distribution. So there are 3 circuits going out. There is the cold water going out that way, the hot water going out that way, and the circulation going out that way. And from there on, it's just like electrical circuits. There's no specific things in that one. If you look at the razor, this is the shaft. So if you look at this cross section of the shaft, and we have different kind of levels up, it's just very banal. We are raising up here, boom, 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 boom. There's no need for really to dive into that, but just to show you an example, for example, we have distribution system at level 2, and here you go. This is how this named then, with different kinds of naming conventions as well, different kind of coding principles from RDS, but it's the same thing with supply. So the point is that while you maybe today are used to look at the drawing right, what you need in the future really to benefit from digitalization is the reference model left, so everybody else can refer to it as well. Because as you can see, we use the codes in our drawings, in our digital models and everything, so you know what you're talking about. If you want the example, if you like it, it's a little bit more extensive than that. I have the flyer with me up here. And if you really, really, really can't wait, then you can scan the code while I'll take a glass of water. Can't wait. When you get it, and you get it on your phone, you have to click the bottom and click share. And then you can simply just send it to yourself. You get the PDF, but you also get a link where you can get it from. So here we go. If you miss it, you'll get it later on by this one. Okay, next step is about how, all right, this is brilliant. I want one and I want it now. And then you go back to your organization and you are filled for today and this is brilliant and we want one. And then you meet all the practical stuff about obstacles. We already got a system that works. And who asks for it, and do we really need to invest in it, and our computer systems can't handle it. And by the way, the equal from that stupid RDS, when you put that into Excel, Excel starts to calculate. I think we've heard all obstacles around it, like anything around it. And of course there will be obstacles, but you need to work with it, you need to work around it, and you need to address what do you do with stupid computer systems that can't handle the codes. And the answer is you need to make workarounds on it, but it's not the workaround that sets sets the agenda. It's RDS which sets the agenda, and the other one are workarounds, not the other way around. Of course it is. Otherwise you're lost. And by practical experience, it's not miracle cure I'm going to introduce you, but just to know what you're facing. When you go home and say, we want RDS, you will probably face this. This is called the law of diffuse innovation. I found it. I have one guy I follow. I'm not particularly fond of these follow stuff, but there's an American guy called Simon Sinek. Have you heard about him? Start with a big Y. No, anyway, brilliant guy, and he refers to this law of diffuse innovation, how you actually make people move. And in fact, Thorleif did the same first time I met him it was the dancing scene, right? How you make people dance on the beach, right? It's the same thing going on here. How do you actually make people follow you? And the thing is that if you think this is everybody that you have to convince, let's assume it's 100 people. When you go home, you have to convince 100 people to work with you. You're looking at this and you read it from left to right, by the way. You can actually divide people into, say, somebody are called innovators. So 2.5% will say, yes, this is what we're going to do. Let's get on with it. You don't even have to explain to me. I like it. Let's get on with it. Okay. And then you have something called early adopters, which are easy to convince. This sounds great. We have to go for the future. We have to go digital. It's a part of our strategy. Let's get on with it. And then you have something called early majority. It's a little bit, maybe we should wait and see what's going on a little bit. And then you have what we call late majority. If everybody does it, I might follow you. I will follow you, don't worry. And then you have the worst ones. It's an English word called laggards. In Danish, it's called smølehoveder. People who, no matter what you tell them, say no, 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 and no again. The problem with smølehoveder is that they are very noisy. And they shout out loud, we don't want that, etc. So this is what you're facing. So how do you create a movement? How do you create a dance there? The good news is that the first 10% more or less goes by itself. You don't really have to work hard for that. It's okay. The first 10% more or less goes by itself. And the good news is when you reach the 16%, you receive a tipping point. And when you receive the tipping point, then the early majority following that, from there on it goes by itself. So the hard work is in between 10 and 16%. That's the good news. The bad news is it is hard work to get there. So I have selected 3 highlights from how we work for moving people from 10 to 16%, and it's just a good advice for you. It's not a miracle cure, as I've said several times, but at least if you follow, but you have to follow all 3 of them, otherwise it will not work. They come here. First of all, I would say you need to join forces between different disciplines. It doesn't help if you come as an electrical engineer and say, we want RDS, and they just say, good luck, speak to you later. You will not make the common language. You'll just say it's an electrical language. We don't need that. So you need to join forces between different kind of disciplines. The most easy guys to convince is, in fact, the mechanical guys or process guys working with diagrams, because it's a kind of same dialect we speak as well. So at least 2, preferably at least 2. then I must say having practical examples to follow is an absolutely must-have. And it's funny to see that people, when we say practical examples, even though I hand out the tap water for you, people say, yeah, but that's tap water. We are doing sophisticated electrical circuits, so that's not the same. So they need something that really speaks to their heart. Finally, but not least, you have to make it super easy to follow. When I say super easy, I mean super, super easy to follow. Don't make a manual of 25 pages with a lot of explanations and a lot of boring codes. It has to be extremely easy, more or less like the game I'm playing with you. Click the barcode and here we go. It's that easy. It's that level we are looking for. And it has to be something that people can see themselves in, and that's actually how we realized this in the Danish construction sector, because we created that result of RDS-CW as the first version in the Danish construction sector. And all the construction guys got all the attention, and we got 20 pages in a PowerPoint for all the installations, and it just didn't work. People say, well, are you fucking kidding me? So, but with the new thing we have created, where everybody gets 8 pages around their own discipline, electrical, mechanical, and so on. All right, why didn't you tell me that up front? It's so easy. Why didn't you tell me that? So the easiness is the thing you need. The bad news is very difficult to make things easy, but that's something you can work on. With these things in hand, we know that we can create a momentum, we can create the movement. But that also means if you, for example, disregard the examples, we have some clients who say, we don't have money for the examples. Don't do it then. It doesn't work. These 3 things. Join forces, practical examples, and super, super easy to follow. Now, I've got a little more thing for that. We also see that sometimes you need a pull from an organization, both for management and users, because going for RDS is an investment. It's an investment. And investments is something you see the benefit of in 3-4 years. I would like to refer to Vestas, which produces the wind turbines, and you probably all know Vestas. All of you know Vestas with the big wind turbines. They have gone for the new Part 10, and their manager says, we consider this to be an investment, and we know that we receive a result in 2 or 3 years' time, but we need to go in that direction. It's an investment. That's a strategy, and that's a management decision. On the other hand, if you don't have management support, forget it. You also need bottom-up support. You need a technical need. We would like to work with this. So it doesn't help that the managers go home and say, we are going to do this if the technicians can't really see themselves in it. Oh, I have to work more, or I work harder, and all kinds of complaints. So we need both things. If you can agree on that one, we always say you need a pilot project to run on that might as well serve as a pilot project as well. And from there on, what we typically see, if it's made correctly, it creates a pull. Why wasn't a part of that project over there? That sounds interesting, and it seems to be pretty good for me. And when my client buys, why wasn't I involved in it? That's called a pull from the organization. Especially if people really start screaming for it. I want it too. Then you have a real pull, and here we go. So now you create the movement. Does that make sense for you? It's something like this you have to consider at least. Besides that, there is a lot of experience that you can get from. First of all, I would be so humble to promote my own handbook that you can get from 81346.com or the Danish Standards webshop. Danish Standards is my publisher. That's why I'm in control of copyrights and all the problematic stuff. I am completely on top of it. I've got contracts and site signatures and everything. So I created a handbook a long, long time ago, also with a kind review from Eric. I think it's the 8th edition or something like that. It's available in Danish, as you can see, in German and English as well, of course. And you can get it from there on as a PDF or as a hardcore copy. In that, you will see a lot of practical examples, a lot of practical advices and explaining the stuff. But at the end of the day, it's a handbook. It doesn't really tell you exactly how to do it. We are the proud owners and also the humble owners of 81346.com. And we do a lot of stuff to share with you, a lot of stuff for free. So if you go to 81346.com and explore around, you can see something about the standards, something about tools and materials and news. And if you want to go, and you are lost and need a hand, you simply just click Get Started, and there you get a contact formula, and then you write us, and then we'll be happy to help you either by just an informal email, some questions you may have. And if you really want to go all in, of course, we can help you with that. But if you are lost, click Get Started, and here we go. Then we have a free thing for you. We have the RDS 81346 app. And the 81346 app is an app for your smartphone, either for Android or for Apple. If you haven't installed it yet and you want to play with RDS after lunch, you need to install it. It's very easy. Go to the stores, search for 81346, and you can't miss it. And then you sign up for it. Because this is how we're going to find the coding principles. You're not supposed to know the coding principle. You're not supposed to know that a pump is a GPA and things like that. That's what the app is for as well. Finally, but not least, we have created a web-based tool that supports 81346. The thing is that there is already a lot of tools that supports 81346, typical within electrical diagramming. More or less, any programmer I've seen that does diagramming handle these codes, but the question is how good they do it. And you have to remember that the diagramming tool's angle is making diagrams and then making a reference model. We took the opposite away. So we make a reference model that the diagrams can use as well. So it's called the SecHub, and the SecHub is a cloud-based tool that looks up the coding principles, etc. for you. In this case, we say it's for further processing by ePlane, but in fact, it's a question of making the reference model robust enough to deal with, and then you can get it from the cloud-based solution and then work continuous with it. So even if your existing system, you have no idea how many times I've heard SAP does not understand RDS. No, in that case, you need to feed SAP with the coding principles from, for example, a tool like this. There's nothing wrong about SAP, but it's designed for something else. So that's just to say that it works. I'm not going to present it for you because this is not a tooling thing. But as you can see, it's system breakdown. And you can see 1 to 3 letter codes. And you can see that you can write whatever. It's a web-based environment. That means that you don't need to update anything. We update it on every sprint, which means every 2 weeks there's an update of different kind of things. And in there, you can also see when you have to search for things, it's the same repository of coding you are looking in. So it's a practical way of building these models. But if you don't like that, you can do it on a piece of paper. You can do it on a mind map. And you can even force Excel to more or less understand what you're trying to do. That also works. But you need a tool somewhere to put it in. Then if you go to YouTube and you search for 81346, then you come to our channel, and as well we have some very good friends around us. We have Erik Viborg Schack here in Norway, who has done a terrific job making some explanatory examples about how to understand RDS. We have a friend in Sweden, and we have some other friends around who also post things around 81346 on the YouTube channels. We have decided to make it more educational, so we have created 7 videos. It's my young friend Philip, who is also participating in the standardization, who's the performer. We had great fun doing it and making them. So if you want to, take a snack of RDS, you just take one RDS snack at a time, around 5 or 6 minutes, and watch it over a cup of coffee. All right, that is what about. And we start from scratch, from absolutely scratch, and that should be pretty easy. And there's also a one explaining about the software at the end. But this is a YouTube channel, and we put something on it on a regular basis. Finally, but not least, you can go to 81346.com, and you can, of course, drop us an email and get some more information if you like to. That should be quite obvious. Spot on time. We are not. No. I'm in control here. You're not, my friend. No, I'm just kidding. No. I have a surprise for you. You was not aware of that, so you're excused. I have a little surprise for you. I would like to change your perception of flying next time you go into a cabin and find your seat. So I would like to share with you. The system thinking, how easy it is at the end of the day. But before we do that, and we get to the Q&A answer, I would like to share a quote with a guy which is a late system thinker. His name was Niklas Luhmann. He was a German Scientologist. And he was thinking in systems not just about the technical area, but also that a society like Norway is a system, and Denmark is a system, and how systems actually work together. And reading his literature is tough. To be honest, I don't really get it. There's a lot of things in it I really don't understand. But I found this one quote that I really, really think nails what we are dealing with. Only complexity can reduce complexity. So if you think RDS, that's a kind of complex thing. The answer is yes, it is, because you use it to reduce the daily life complexity. If you think of it, the keys and notes we were discussing before from music, that's quite complex, isn't it, when you look at it? But you use it to reduce the complexity of music so you can convey it. And it's the same thing going on here. And so the thing is, you need the complexity to reduce the complexity. So if you look at a mess, which is a complex thing, you need another complexity to reduce it with. And it's actually true the more you think of it. Then we go to Airbus. I was flying Airbus up here with SAS, by the way, and every time I go into that cabin, I can't just help looking around, looking at the systems we have created. The story with Airbus goes back to 2017, where they have a very big ambitions about going digital in what they call the DDMS program, which is Digital Design, Manufacturing and Services, and they wanted a digital thread from very scratch to beginning. And they realized that they didn't have a common language about the thing that they conveyed. It's easy enough to make, small parts that make it work together, but the large picture was missing. I mean, if they really wanted to go all on and model that, how to do that. So we started working with them in 2017, and the first thing they had to do was to teach me and my colleague what is an aircraft. How does it actually work? How does it fly? What do you do when you fly with it, etc. So that was a journey. We started there, and to cut a long story short, we ended up in things like this. You should from now on, even on a distance, see, this is a reference model. This is a reference model. They ended up there. And what I would like to say is that on the right side, you see something called processes. It doesn't mean a process, but it's something you do. The story behind that one is that Airbus has manufacturing locations in US and in China, but also, of course, in Europe, mainly in Germany, in France, in Spain, and the UK. And they didn't have a common language when they wanted to do something in their factory. For example, such a banal thing as drilling a hole. Because you don't just drill a fucking hole in an aircraft. Are you absolutely not? That's about the last thing you do. So they needed a common language to express in the model how you do things like that. The processes. First you inspect, and then you inspect, and then you verify, and then you drill, and then you verify, and you adapt, etc., etc. So we ended up making that library for them, and that's the new part 50 pending that you were mentioning in the beginning, Christopher, and that's the new one that you probably mentioned as well. And that's the reference model we ended up with. To be able to do that, it's very seldom I tell this to people, but I would like to share with you that I think I'm the most lucky engineer in the whole world, because I was invited to see all manufacturing sites from Airbus in Europe. It was a tough tour, but it's unbelievable big. It's enormous, it's gigantic. Take an Orvik, piece of cake. But that one, it's really is unbelievable. How do you handle that? You add RDS. You add RDS, believe it or not, because you can create models out of it, and you can express what you're doing. I mean, wow, this is cool. It sounds easy. It took a while to figure that out, but anyway. Now, I promised to change your way of flying, and it's coming here. Next time you are looking for your seat 12A, you're looking for a seat, but it's actually a part of a seating system. Because when you think of it, when you look at it, the seat is actually a small part. There's a frame, there's an armrest, there's a cup holder, there's a coat hanger, there's a table chair, and so on. The least part is actually the chair, the seat, and the back seat as well. That's the least part. So you are a part of a seating system. And to be able to handle that, we have something called definitions. So there's a definition behind it, and I'll come back to that one after lunch. It's called a technical system which fits out space for person seating. It should be a piece of cake, but the point is, again, you need a definition to be able to address it, and that's what we are going to address later on, that working with definitions is the hard stuff that we are doing for you. We'll get back to that one. Before we get the Q&A answer, I would like to share with you Maestro music. We would like to share with you a little commercial flight video from YouTube, just 2 seconds before you press start. And what I would like you to do and invite you to do is to think in systems. I would like to claim that anything you see on that one, even the pilots, are considered to be systems. Let's go.
Going to brief this family flight. The formation will be an echelon with fixed aircraft. We will perform the brake, full or roll stick, up to 30 degrees of bank angle, and it is very important to maintain the altitude.
Everybody ready?
Ready?
left trading 200, the 319.
Left 200.
Okay.
330, size of 350.
Okay, 330, okay, to join up the 350.
Okay.
Falcon is ready for break. Are you ready, guys?
330 ready. 319, 220.
For left and break. 3, 2, 1, stop. 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 Stop.
Thank you. So yeah, what's not to like? I mean, flying engineering beauties, isn't it? Did you see the pilots? If I claim they are a system, what kind of system do you think they are? It's a system we actually not particularly fond of. It's called a decision system. Because sometimes we make good decisions, sometimes we make not so good decisions. So to be able to model it, you need to represent it as a system. By the way, we got sensors, don't we? We got light sensors called eyes. We got ear sensors, etc. Sound sensors, and so that you really can model it like that, and RDS can handle it. You didn't like to put in the eye as an example for a sensor, but nevertheless, I still think it's a good idea. But let's see about that. Time for Q&A. Time for Q&A. All right. Does it make sense what I'm trying to say here? I mean, you need to get this fundamental stuff to understand what you're dealing with. But when you get that, you are definitely on the right path. Questions?
Stille spørsmål, kan ta den mikrofonen.
Yeah, you need a microphone because we also got audience on remote. Hello, remote. So they can be able to hear what you are saying. So I don't need to repeat your question. Yeah, Torleif has a question up here. 14. Maestro, slide 14, if you would be so kind. A way to go.
I can raise the question first. It's about these different industries and interfaces, and you're referring to manufacturing, and I'm wondering how do you interface with the Industry 4.0 and this asset administration shell? Is there some work going on there?
For what? Sorry, one more time.
For the manufacturing industry and Industry 4.0 and the asset administration shell, they are focused very much on now as part of the Industry 4.0.
Yeah. Well, the idea about this one is that part 14, which is about manufacturing, is the same thing that we have, for example, a machine manufacturer like Tetra Pak. producing the machines on which you buy the milk cartoons from. And they needed a language that they speak in terms of what they're doing, because they're doing something else than flying an aircraft. And I still think what we are aiming at here is in the standard series is that we would like to aim to have different kind of industry parts that goes hand in hand, that you can work depending on what you want to model. So you have to find the appropriate part of the standard so you can model whatever you like to model. And to lower the barrier, to make it super easy, or at least as easy as possible, we have by coincidence or by practical things tried or decided to make these industry specific, but they work in the same way. The price we have to pay is that the code does not necessarily mean the same thing in different industries, but that's the price we have to pay. In reality, it's not a problem. I hope it answers your question. Yeah? Any other questions? Yeah, over here. Thor has a question too.
So when you model processes, a process in one way can be seen as producing an artifact, right? Can you extend 81346 so you can model, say, an engineering design process that results?
Yeah.
And then, so you are in fact, you both have a product or artifact asset view and an activity creation view in this?
Yeah,
is that part of manufacturing systems?
In manufacturing, you get the box with the Lego bricks. The way it has to be understood. You remember the triangle with the Lego bricks? No? Do you remember the triangle with the Lego bricks? Yes, you do. Try. In that box, you will find the appropriate Lego bricks that you can build a model depending on what industry you're in. And based on that one, you can build any model that you refer to.
So you can model, for example, the verification process.
Yeah, absolutely.
Okay. Great.
Yeah. Two questions to go, and then I hand over the microphone to. Yeah.
A question about implementation for operation perspective. If you have several plants or assets, boundary limits for, in your examples, was up to a system.
Yeah.
And how to implement for the several plants.
Yeah. First of all, if you have existing plants, you'll bump into that they have an already existing numbering system of some kind. And you'll probably have resistance about changing it. And we say, don't change what we already got, but you might need a model next to it that you can refer to. That means that you need to make a mapping between the old way of doing it and the new way of doing it. You're not supposed to relabel anything you got in the asset, but you can create a new model that can actually handle anything you have in front of you. And we have the thing going on for the moment. We have a project for LKAB in Sweden, the big mining company in Sweden, where they have a huge amount of mining complexes, and they want to keep what they got, but they also want to go digital in the future. So they keep what they get, and we create a new overlayer model, so to speak. And in that one, you also address what kind of assets are you looking at as well. So you create a model that reflects that perspective. And RDS can do that for you. One question to go, and then it's my turn to hand over the microphone. Yeah. Trolaf, you again.
Yes, not me really. It's Bent from a colleague follow us online, and he asked him what is giving the functional location in SAP. Which aspect is that?
I have no idea how SAP deals with that, to be honest. And to be honest, I would say that's a classical obstacle you get. How does SAP deal with this? And to be honest, I don't know. And I don't think it's a problem of RDS, how SAP deals with it. It's the other way around. This is RDS, how would SAP like to deal with it, so to speak? Yeah? And I think with these words, thank you very much.